Hey there, intermediate algebra students. It's time for the last online lesson from Chapter 6. As you can see, parallel and perpendicular lines. I think this is something you guys know about, but we'll be using it in constructing some equations and making some decisions about equations as well. Anyway, I think you have a feel for what we mean by parallel lines. Parallel lines, of course, never intersect. That's the main definition of them. And here's something you may or may not know. They have the same slope. We've been focusing a lot on slope in this chapter, of course. So parallel lines have the same slope. And so if we draw a parallel line, a line parallel to the one we've given here, of course, it would look something like this. And this one has a negative slope, as that white line does there. So those lines are parallel. Now, what about perpendicular lines? Well, perpendicular lines, I think you have an idea that they intersect at a 90-degree angle. And here's something that is a little bit strange. The slopes of perpendicular lines are opposite reciprocals. We'll talk about that on the next slide. But if I were to draw a perpendicular line, of course, to this white line, it would look approximately like this. And you may remember the symbol we use for perpendicular is that little square that connects the two lines that are perpendicular. Alright, let's actually examine some situations about slope here of perpendicular lines. Next chart, I'm going to draw some slopes in here, and then we'll try to figure out what the perpendicular slope would be. By the way, the symbol for perpendicular is an upside down T. You may have known that, but we'll just write that in there for you. Alright, so let's take a look at some slopes. I'm just going to write down some slopes here. The first one is going to be 2/5, and then -7, and then the slope I'm going to use, next one is going to be -1/5, and the last slope I'm going to use is A. Alright, now we'd like to see if we can figure out what the perpendicular slope of those to those lines. So remember, we have the opposite reciprocal. So the reciprocal, I think you have a feel for what that means. That's flipping the numerator and denominator. And then by opposite, we mean that the sign has to be different. So anytime you have a positive slope here, then the perpendicular slope must be negative. So we'll go ahead and write these examples. The perpendicular slope to 2/5 would be -5/2. So the reciprocal and as well as the opposite sign. For -7, now you might wonder what's the reciprocal of -7, but remember -7 is 7/1, so then it would be 1/7, and it would be positive because this one here is negative. Alright, -1/5, again, if I flip that, I'm going to have just +5, or 5/1, but probably easier just to write 5. And what about if I have the variable a? Well, a we can really write as the fraction a/1, so then it might be a little bit easier to see that the opposite reciprocal of that would be 1/a with a negative sign in front. So that gives you some example of what the slopes of perpendicular lines would look like. Examples here. First of all, we give you a couple lines, and we want to know, are these two lines going to be parallel, perpendicular, or neither? Now the first one here is in standard form. That's a little bit trickier to find the slope. So if you remember what we did on these, we tried to solve them for y. So in this case, I'm just going to go off to the side here and see if I can solve this for y. So I would subtract 3x from each side. That would be my first step here. And then I'd get -7y equals -3x plus 1. I would divide by -7, like that. And so then I'd get y equals, now -3 over -7, that would turn this to be +3/7 x. And then this, my y-intercept then will be -1/7. we'll see the y-intercept doesn't really matter too much on these kind of problems. Alright, and then of course on my other one here, y equals negative 7/3 x plus 5, the slope is sitting right there for me. That's that negative 7/3. So anyway, I just need to really compare the two slopes. What about negative 7/3 and positive 3/7? Well, they're not the same, obviously, so they can't be parallel. Can they be perpendicular? And the answer is yes, because indeed these are opposite reciprocal slopes of each other, and so therefore I can conclude that these two lines are perpendicular. There's my symbol for that. So you might need to do a little rearranging of things, but again, we're just mainly focusing on the slopes of these two equations. Now we get into some that are even a bit tougher, I think, sometimes. Write an equation in slope-intercept form. So that's my y equals mx plus b of the line that passes through 2, negative 3 and is parallel to this line. Well, again, as is often the case with a lot of things this chapter, we want to focus on slope. And so certainly the slope of this line here is going to be negative 2. Remember, we used the letter m to represent slope like that. So the question is, when I write my new line, do I want the same slope or something different? Well, we remember that parallel means the same slope. Same slope. So I think I'm going to start with the point slope form. That's always a good one to start with, I think. And so I'm going to do that here. And then I'm just going to fill in some stuff that I need to know. Remember, this point here would be my x1 and y1. That's your given point. And I do know the slope I want. So here we go. It's going to be y. My y value is negative 3, so minus a negative is like plus 3. My slope in this case, remember, I want the same slope because we have parallel lines here. So negative 2 and then x minus 2. That's my point slope. Now I just need to fix this up a little bit. Slope-intercept form, remember, is just getting the y by itself essentially. So I'm just going to mess around with this slightly. I'm going to distribute this negative 2, so it's negative 2x plus 4, like that. Then I'm going to subtract 3 from each side, and that should do it for me. So my final answer would appear to be y equals negative 2x plus 1. Again, that's a line that's going to be parallel to the given one. It's going to go through this point. And you can tell because the m value or the slope is negative 2 in each case that would be true. Next slide. Same type of question, except now we're talking about perpendicular. Perpendicular. So if this is the slope right here, m equals negative 2, what's my perpendicular slope going to be? Well, my perpendicular slope is the reciprocal of negative 2, which is 1/2, but it should be positive 1/2. So I'm going to use my point slope form again, so it's going to be y plus 3. This is the same point actually, but this time I'm going to use a slope of positive 1/2 in my point slope equation. And again, I'm just going to distribute this best I can. So I get 1/2 x, and 1/2 times negative 2 is negative 1, like that. I'm going to subtract 3 from each side, so my final answer here becomes y equals 1/2 x minus 4. Again, same points, going reference to the same line, but this time perpendicular instead of parallel, and you can see my equation then is a little bit different. Again, these are some of the toughest equations we'll have, I think, in this particular lesson, just trying to keep everything straight. But I know you guys will be able to do. To leave you with a couple of little cartoons here, just remember that parallel lines have the same slope, and perpendicular lines have those negative reciprocal slopes. All right, we'll work on this in class actually for the next couple days, so we'll see you guys then. Bye now.